Okay, we are back, and this is chapter 3-1, and this is recording number 3. All right, so what we did up here was we've calculated the x bar, that's the mean, and because it's x bar, we know it's a sample, not a population. So that was for actual data points, 1, 2, 3, 4, 5 data points. Up here we had 9 data points, okay? Well, what we learned in a previous chapter was how to do this grouped data. So we use the group data oftentimes when we have hundreds and hundreds of data points, okay? So it's not practical to try to add up all of those data points. We've already put it into a frequency distribution of some sort and some sort of group data. So now what do? How do we find out what the mean is of this grouped data? Well, what we do is the following, okay? We assume that the mean of all the raw data values in each class is equal to the midpoint of the class. Now, does that make any sense to you at all? Probably not. Let's see if we can figure this out. Now remember, this A, B, C, D up here, this A, B, C, D up here, that's an artifact. That's what's left over from the fact that we're using Excel. That I wish he wouldn't have done that. I love this book, but he leaves that in there and he doesn't explain what it is. So that A, B, C, D, that's just left over from Excel. Okay, so we have this class. Here's a what are we talking about here? Some sort of salaries or something for the top CEOs. So here's the class boundaries, class boundaries, class boundaries. Okay, there's 13 people, 13 guys or gals in this class. There's 6 in this class. There's 4 in this class, okay? What we're going to do is we are going to basically say, well, I don't really care exactly what the value is for each of these 6 people. Let's take this one right here. I don't care exactly what the value is for those 6 people. It's somewhere within this class boundary, somewhere in this interval. It's somewhere between 20.5 and 25.5. It's somewhere in there. And there's 6 of them. I'm going to approximate. I'm going to come up with an approximation. I'm going to estimate, or some people might say guess, but it's a pretty scientific guess. What I'm going to basically say is, okay, I'm going to assume that I can represent this entire interval here by its midpoint. And if I represent it by the midpoint, that's good enough, okay? It's good enough for government work for me to just use the midpoint here. That's what he's saying right here. It assumes that the mean of all the raw data values in each class is equal to the midpoint of the class. So the mean of this class is the midpoint. Now that's not necessarily true, but it's close enough, is basically what he's saying here. In reality, this is not true, since the average of the raw data values in each class usually will not be exactly equal to the midpoint. However, this gives us an acceptable approximation of the mean. Some values will be above the midpoint, some values will be below the midpoint for each class. The midpoint represents an estimate of all the values in the class. Okay, so it's an approximation, it's all we can do. All right, so how do we do this? Okay, so you have to find the midpoint of each class, you place them in a column, multiply the frequency by the midpoint of each class, and then place that product in column D. That's the F times X sub M. So this X sub M, that's the midpoint. Okay, F is the frequency. And then, of course, you have the class here. Now, why do we do that? The reason we do that is because if there's 6 guys in this class, what's the midpoint there? Midpoint of that guy is 23, okay? So there's 6 guys in there. 6 times 23 is 138. That's our approximation for adding up each of those 6 guys. I don't know what those values are, but let's suppose I did and I added them up. Each of those 6 guys, I added them up. It would come pretty close enough for our purposes to add up to be 138. It'd be a little bit more, it might be a little bit less, but it's close enough. So I do that for each one of these classes. So it's the midpoint of the class times the frequency, and that gives me the approximate value of adding up all 13 of these guys in this class, all 6 of these guys in this class, all 4 of these guys in this class, and so forth. That gives me the approximate sum. Do you remember what sum means? S-U-M. S-U-M, sum, means add them up. So that gives me the approximate sum of each of these values. Now, obviously, I could do this a hard way. I could go back to my raw data. I could write down all of each of those points, and I could add them up. The reason I don't do this is because, yeah, I could do that for 18 data points. I could do that for 23 data points, but I couldn't do that for 587 data points in each of these classes, right? I mean, it's just too hard, right? And that's why we're using the group data to begin with, is to make our life a little bit easier. So the bottom line here is the formula is the same. This X bar is the same. It's the summation. You add up all of the values, that goes on top, and on the bottom, you divide by the total number of data points. And that's a close enough approximation to what we're looking for. Okay? So it's the same exact formula. We're just getting there a little bit differently. Instead of knowing the exact values of all 18 data points, all 23 data points, and so forth, what we do is where am I here? Instead of knowing the exact values of all 13 of these guys, all 6 of these guys, all 4 of these guys, we approximate the values by saying, well, it's approximately equal to the midpoint. So I've got 13 of these guys. Each of them has a value of approximately 18. So 13 times 18 gives me the 234. Over here, I've got 6 of these guys. That's my frequency, 6 of these guys. Their approximate value is 23. That's the midpoint. So 6 times 23 is the same as adding up all 6 of these guys. 23 plus 23 plus 23 and so forth, okay? So that's how we get the top guys here. And then you add those guys up, and that gives you the summation that we need for the X bar. Okay, I hope that helped. I'm telling you, you just got to do a couple of these problems, and then it'll become much more clear. Okay. All right. So that was the mean, the so-called arithmetic average. I think he's what he called that. Yeah, he called that the arithmetic average. All right, so now let's talk about the next common one that we use, and that's called the median. So a lot of times when someone says the average, they might mean the median as opposed to signifying the mean. The mean is the halfway point. It's the midpoint of the data array or the data set, okay? All right, so here's an example of what we're talking about, okay? Where you see this in our common everyday life is whenever you see an average, when they talk about the average price of houses, that's the median. That's not the arithmetic average, it's the median. So half of the houses are priced above that number, half of them are priced below that number. So that just happens to be a true fact that I'm aware of. Okay. So in order to do this, it's a little bit tedious. If you're going to find the halfway point in this data set, you have to arrange them in order. They have to start with the smallest, the next smallest, the next smallest, go all the way up to the biggest number. Okay. So when you order it like this, it's called a data array. The word array just means they're just lined up in some fashion. Okay. So the median will either be a specific value that's actually in the data set, if it's right there in the middle, or if you have an even number of data points, you don't have a person that's right there in the middle. What you have to do is you have to find you'll find a value that's between two values that are there. Okay, we'll see the examples here. It's hard to say it, but once you do the problem, it's really straightforward. Okay. So here's the definition. The symbol is MD. I'm not sure where that comes from, but MD is the median. Okay. So here's what he wants you to do is you line them up. So let's talk about tablet sales. Okay. Here's the number of tablet sales in millions, blah, blah, blah. You got these numbers here. You put them in order. Okay, the smallest guy is 17.6, the next biggest guy is 69.8, and so forth. Okay, there's an odd number of data values. So if you pick this guy right here, half of them, 2 of them are bigger, 2 of them are smaller. So boom, there it is. That's the median. Very, very simple, right? Let's look at tornadoes. We got all these tornadoes here. Okay, and you line them up. There's an even number, right? 1, 2, 3, 4, 5, 6, 7, 8. So you can't pick the 4th guy, because then there would be 3 below and 5, or 3 below and 1, 2, 3, 4 above. So you can't pick this guy. You can't pick this guy, because the same remarks apply. There'd be 4 to the left and 3 to the right. So what do? You pick you take these two middle guys, and you go halfway in between them. So what's halfway between 764 and 856? Well, add them up, divide by 2, boom, there it is. So 810 is the median number of tornadoes. So just like before, for the mean, we did not need to have a value for the mean that was an actual data point. Same thing here. 810 is not one of the data points. It doesn't have to be. It's just right in there. Now, an exercise for the student, add these guys up and divide by however many data points there are. Yeah, 8 data points, and see what the average is. See what the mean is, and you'll see it's not exactly the same number. But that's okay. I mean, it doesn't matter as long as you are being truthful. Whenever you talk to somebody and you tell them, well, this is my data, and you say this is the average, and he says, well, is that the mean or the median? Just tell him the truth. Tell him it's the mean or tell him it's the median. Depends upon the context, whether you use the mean or the median, or maybe it doesn't make any difference. Maybe they're basically the same, close enough for government work, and you don't care which one you use, okay? What you'll find is that, as an example, mean and median. Let me explain this, and then we'll end this video because I'm almost out of time. The reason it's important sometimes, not always, but sometimes, is that the classic example is, let's say we're in the classroom right now, okay, and there's 45 of you folks, and I'm standing up there, so there's 46 of us, and I say, what's the mean salary? Or let's say mean net worth. So we all add up all of our possessions, and we come up with our average net worth. And let's just make up a number. Let's say, 1 or 2 of us own a house, 1 or 2 of us got nothing, whatever it happens to be, we come up with a number. Okay, say I'm going to make it up, $20,000. Okay, so that's the average. Well, then Bill Gates, or the guy that owns Facebook, whatever his name is. I don't do social media, so I can't remember his name. So one of those 2 guys walks in the room and says, hey, Mr. Cantrell, I would sure like to take this class. Oh, okay, sure, you can take the class. Let's put your net worth into the mix here. Okay, that guy is worth, $1 bazillion. So now the average would go up significantly, okay? It would be very, very, the average if you were measuring it by the mean. If the mean would go up so much that that number would be meaningless, right? On the other hand, if you were using the median, it wouldn't go up very much at all, because he would be, if there's 45 students, he would be, let's say there's 44 students, he would be student number 45, so half above and half below, it would just move that pointer just a little tiny bit to the next guy, for example. So it wouldn't be that significant of a change. So having Bill Gates walk into the room doesn't really change the median by that much, but it changes the mean so much that it makes the mean totally without any meaning for our classroom. Okay, so I hope that's a good example. I hope that explains it. Okay, so I'm almost out on this video, so I'm going to stop it now, and then on the next video, we'll talk about the mode.